Assalamu alaikum students, I am Nauman Saleem and we are here to verify Ohm's law. Let me first introduce you the apparatus of this experiment. We have an ammeter. This ammeter is used to measure the amount of current in a circuit. There are three terminals in this ammeter. One is negative terminal and the other two are positive terminals each. These two positive terminals show you the range of an ammeter. It has two different ranges. One range is 0 to 0.6 amperes, you can see clearly, and the other range is 0 to 3 amperes. We have a voltmeter. Voltmeter is used to measure the amount of potential difference across the resistor. We have three different terminals in this as well. One is negative terminal and the other two are positive terminals each. These two positive terminals here as well show you the range of voltmeter. It also has two ranges. One is 0 to 3 volt and the other is 0 to 15 volt. We have got a fixed resistor. This resistor looks like that, but it is actually like this. You can see clearly there is a very small resistor. It is made up of ceramic and it has different colored bands. These bands are used to find the resistance of this resistor. It is kept in plastic case, so if it gets heat up and you touch it, you don't get hurt. We have got a pair of cells. These cells are connected in series to form a battery. Each cell has an EMF of 1.5 volt. Collectively, they form a battery of 3.0 volt. We have a variable resistor. This resistor is also called rheostat. It has a sliding contact. We can slide this contact to change the resistance or maybe current in a circuit. We have a key. This key works as a switch. If you take this key off like this, it is an open switch, means no current is flowing through a circuit. And if you insert the key like this, there is a closed switch and current will be flowing through the circuit. Now let me show you the circuit diagram of this experiment. You can first of all see the power supply or a battery is here, and a switch means the key is connected in series with the power supply, and then an ammeter is connected in series, again in series, and then a fixed resistor is connected in series, and finally the variable resistor is also connected in series combination. All those components what I have already discussed are in series combination, but there is one component which is voltmeter, which is always connected in parallel combination. So it is connected in parallel combination with the fixed resistor or across the fixed resistor. Let's now make a circuit. I'm starting with positive terminal of the battery. You can see clearly I'm connecting positive terminal of the battery with a wire and crocodile clip like this, and then I'm connecting this end to the key which is working as a switch now. Okay, now I'm going to connect the other end of the key or switch to the positive terminal of an ammeter like this. I'm connecting it with a smaller range because now we do not have large amount of currents. Okay, now I'm going to connect the other end of the ammeter with a fixed resistor. Okay, and then the other end of the fixed resistor with a rheostat. Keeping in mind rheostat is a complex device like this. You can see clearly that there are two lower connections in rheostat and two upper connections. Okay, at one side if you are connecting with the upper connection, at the other side you have to connect it to the lower connection, so you can use this sliding contact and vary the amount of resistance. If you connect these two lower ones in your circuit, you will not be able to change the amount of resistance. Okay, this resistor will behave like a fixed resistor. Okay, right? So you better connect one end with the upper one and the other end with the lower one like this. See, here I'm connecting with the lower end and here I'm connecting with the upper end like this. Then the last end is left and this end is connected to the negative terminal of the battery. The circuit here completes. Now check once again. Battery is connected with switch in series combination, and ammeter again in series combination, the resistor series combination, variable resistor series combination, and connected to the battery again. See, there is a series combination. There is no other path of current to flow anywhere else. Okay, current through this battery, through the switch, through the ammeter, through resistor, this fixed resistor, or through this variable resistor, all the currents will remain same. In series combination, current always remains same. Now there is one thing left, which is voltmeter, and voltmeter is always connected in parallel combination to the resistor, because we are finding the voltage across the resistor. See, now I'm connecting this voltmeter in parallel combination, and parallel combination is formed like this. One end is here and the other end is here. Now there are two wires like this. End is connected to this 3 volt, and the other end is connected to the negative terminal of the voltmeter. The circuit is complete. Now you can use this switch, to insert the key to close the switch and start the experiment. Keeping in mind, switch this circuit on for a very short interval of time to avoid the resistor to get heat up. Let's find out the readings. Meter and ammeter, and set this value of resistance to be very high, so the amount of current through the circuit should remain low, and insert the key. When I insert the key, I just move this slide this sliding contact in this way, and the value of voltage is coming 0.6 volt. Okay, it's on 0.6 division, and on the other end here it's on third division, and third division means 3 multiplied by 0.02 to get 0.06. It means the value of voltage is 0.6 and the value of current is 0.06 amperes. Okay, please note down the readings. I repeat, 0.6 volt and 0.06 amperes. Okay, I would not keep the switch on for longer time to avoid the resistor to be heated up, as I already told you. Okay, now I'm going to insert this again, and I'm going to change this value of resistance, and increasing the amount of voltage. Maybe I set it at 0.8 volt, and 0.8 volt here, and it's on fourth division. 4 multiplied by 0.02 again to make it 0.08. Okay, I repeat, I want you guys to observe it again. Write the observations. Its value of observation is 0.8 volt, and its value of current is 0.08 amperes. Okay, this is the second set of readings. Now I'm going to find out the third set of readings. I'm again inserting the key. I'm going to change this resistance, and I set it 1.0 volt. You can see clearly it's 1.0 volt, and here you can see it's on fifth division. 5 multiplied by 0.02 to give you 0.1. Okay, so the value of voltage is here. The third set of reading is 1.0 volt and 0.1 amperes. I repeat, 1.0 volt and 0.1 amperes. Okay, this is the third set of reading. Now we are going to find out the fourth set of reading, and I'm setting this voltage to maybe 1.2. Here it is, 1.2 volt, and it's coming on 6th division, nearly 6th division. Okay, 6th division, again 6 multiplied by 0.02 to get 1.2. Okay, 0.12. So it's going to be, see, I repeat, it is going to be 1.2 volt, and it's going to be 0.12 amperes. Okay, now I'm going to insert this key again, and I increase this voltage to maybe 1.4. Okay, 1.4 volt, and here I find on 7th division. Okay, 7 multiplied by 0.02 gives you 0.14. Okay, now the last set of reading will be found, and it's going to be, maybe I'm going to set it at 2 volt. Okay, fine, it's going to be 2 volt here, and here what I find, 0.2 amperes. Okay, so I repeat, the last set of reading is 2 volt and 0.2 amperes. Okay students, now let's discuss the observation table. See, first of all, we are going to write down the readings of voltages here with its unit, volt. About current, which is taken in amperes, and lastly we are going to calculate the resistance, which will be calculated in ohms. Okay, so it's necessary to write the quantity slash unit, quantity slash unit, quantity slash unit. If you remember, we had first taken the value of voltage as 0.6 volt and the current was coming 0.06 ampere. Okay, resistance is always equals to voltage upon current. So you know, if you take voltage here, which is 0.6 upon current, which is 0.06, so the answer comes 10 ohms. Okay, here we have one significant figure, here we have one significant figure. So what we can do, we can even take it to one significant figure, right? 10 ohms. Let's discuss the second reading. Second reading is, if you remember, 0.8 and it was 0.08. Again, you know, when we calculate, so the answer comes 10 ohms. Here we go. Okay, third reading was, if you remember, 1.0 and it was 0.10, and again the answer comes 10. You know, when you mention the units here, you don't need to mention the units with the quantities, you know, with each quantity like this. Number 4 reading was 1.2 amperes and it was 1.2 volt, 0.12 amperes, and the answer was again coming 10. And fifth reading was, I remember, 1.4 and this was 0.14. Again the answer is coming 10. And the last reading was 2.0 and this is going to be 0.20, and the answer again is coming 10 ohms. Okay, this is actually going to be the observation table. Okay students, let's talk about graph. Here we have made two axes, x-axis and y-axis. On x-axis, what I'm going to take potential difference in volts, and on y-axis I'm going to take current in amperes. Okay, this is must to level. Secondly, we have formed a linear scale. You can see 0 starting from 0, 0.2, 4, 6, 8, 10 and going on. Okay, in the same way, on y-axis 0 starting from 0 again, you know, 0.2, 4, 0.02, 0.04, 0.06 and it just goes on and on. Okay, right? Let's now take the points. If you remember, our first reading was, as I've taken voltage on x-axis and current on y-axis, because voltage is a independent quantity and current is a dependent quantity. That's why I've taken voltage on x-axis and current on y-axis. Okay, so see, first reading was 0.6, 0.06. So let's take this point, which is 0.6 and 0.06. Here you go. This is the first point. Try to take crosses to avoid the errors. Okay, then we had another reading 0.8, 0.08. Okay, let's plot this point as well here on our graph paper or on a grid. Next point was 1.0 comma 0.10. Okay, and it was here. Next point was 1.2 comma 0.12, and this point was 1.2 comma 0.12 here. Okay, and the next point was 1.4 comma 0.14. Okay, so this point is coming here, and at this. Okay, and the last point, sorry, second last point was I think 1.6 comma 0.16. Let's take this point as well. And the very last point what we had taken was 2 comma 0.20. I think we should have taken here one more point. We missed it, it doesn't matter, as we are only verifying the law, so it's not going to be a big deal. Okay, the last point was 2.0 comma 0.3. Right, now if we draw a straight line, or if we draw a best fit line, so we are going to get this line as starting from here, suppose starting from, let's say, here, and try to get the best fit line. Fortunately, I'm getting the best fit line through all the points, and even this best fit line is passing through 0, 0 as well. Okay, your actual line is till here only, but if you extend it, so it's passing through 0, 0 as well. Okay, right, this is going to be my best fit line. Best fit line is coming correct here in this case. Okay, so by this graph your law is verified, because the law states that current is directly proportional to potential difference. Okay, current is directly proportional to potential difference. It means directly proportionality has a graph of a straight line passing through origin, and we are getting a straight line passing through origin, right? If we talk about the gradient of this graph, so gradient equals change in y upon change in x. On y-axis we have a current, and on x-axis we have a potential difference. Okay, basically resistance equals to V upon I, right? This is the formula of resistance, but here we are getting I upon V. It means this gradient, which is represented by M, is coming 1 upon R. So keep one point in your mind, that in this kind of graph, gradient will give you the reciprocal of the resistance. Okay, in other words, you can say, if we have another straight line, suppose if we have another straight line like this, okay, like this. Okay, so the one which has higher gradient means the higher slope has lower resistance, and the one which has lower gradient has higher resistance, keeping in mind. Okay, so thank you so much. Our law is verified.